Welcome learners. I welcome you to the session, the selection of material handling equipment. The selection of the material handling equipment is considered to be an important decision as it affects the cost and efficiency of the handling system. We shall now see the factors which are to be considered while selecting a material handling equipment. The major factors are the properties of the material, the layout and the characteristics of the building, the flow of production, the consideration of cost, the nature of the production operations, the engineering factors, and the equipment reliability. We shall now see each of the factors in detail. The material properties. Whether the material is in a solid form or a liquid form or a gas form, and whatever may be the size, shape and weight, it has to be undertaken for moving it. They are said to be the major consideration and can lead to a preliminary elimination from the range of available equipments under review. If the material is considered to be fragile or corrosive or toxic, this will imply that certain handling methods and containers will be preferable to the others. So the properties of the material will decide upon the type of material handling equipment. Another main factor is said to be the availability of space in a building, the layout of a building. The low-level ceiling may preclude the use of hoist or the cranes, and the presence of supporting columns in awkward places can limit the size of the material handling equipment. If the building is multi-storied, chutes or ramps for industrial trucks can be used. Layout itself will indicate the type of production operation, whether the operation is said to be continuous or intermittent or in a fixed position. So this layout will indicate the type of production process and indicate the item of equipment which is more suitable than others. Floor capacity also helps in selecting the best material handling equipment. The production flow is said to be the third main consideration. If the production flow is fairly constant between two fixed positions that are not likely to change, then fixed equipment like conveyors or chutes can be successfully used. If on the other hand, if the production flow is not constant and the direction of the flow changes occasionally from one point to another because of several products produced simultaneously, the moving equipment like trucks will be preferable. So the trucks can be selected when we have the changes in the direction of the flow of production. The cost consideration is also said to be the most important consideration. The production flow, the building layout and the material properties may help to narrow down the range of a suitable equipment, while the cost consideration will help in making a final decision. Several cost elements need to be taken into consideration when comparisons are made between various items of equipment that are all capable of handling the same load. Initial investment and operating and maintenance costs are said to be the major costs of the handling equipments. By computing and comparing the actual cost for the items of equipment under consideration, a best decision can be taken on with the appropriate choice. Selection of the equipment also depends upon the nature of operations, whether the handling is said to be temporary or permanent, whether the flow is continuous or intermittent, or whether it is horizontal flow or vertical flow. So depending upon the nature of operations, an equipment can be selected. The selection of material handling equipment also depends upon many engineering factors like the door and the ceiling dimensions, floor space, floor conditions, and the structural strength. The reliability of the equipment and the supplier's reputation and the after-sales service also plays an important role in selecting the material handling equipments. So while selecting the material handling equipments, the material properties, the layout of the building, the production flow, the cost aspect, nature of the production operations, the engineering factors, and also the supplier's reliability and reputation should be considered. Next, we shall see about the categories of material handling equipments. The material handling equipments can be classified into two main categories as fixed path equipments and variable path equipments. Fixed path equipments will move in a fixed path. The conveyors, the tubes, fully drive equipments will belong to this category. A slight variation in this category is provided by the overhead crane, which though restricted can move the materials in any manner within a restricted area by virtue of its design. Overhead cranes have a great range in terms of hauling tonnage and are used for handling bulky raw materials, stacking, and at times palletizing. Variable path equipments have no restrictions in the direction of movement, although their size is a factor to be given due consideration. The trucks, forklifts, mobile cranes, and industrial tractors belong to this category. Forklifts are available in many ranges and they are movable, and various attachments are provided to increase their versatility. The material handling equipments can also be classified under another 5 major categories like transport equipment, positioning equipment, unit load formation equipments, storage equipments, identification and control equipment. The transport equipment are used to move material from one location to the another, that is between the workplaces or from the storage area to the workplace. The subcategories of this transport equipments are cranes, conveyors, and the industrial trucks. Materials can also be moved manually without using these equipments. Positioning equipments. Equipments used to handle the material at a single position. For example, to feed materials so that they are in a correct position for subsequent handling or machining or transportation or storage. Unlike the transport equipment, positioning equipment is usually used for handling at a single workplace. Materials can be positioned manually without no equipments. Unit load formation equipment. These equipments are used to restrict the materials so that they maintain their own integrity when handle a single load during a transport and for storage. If the materials are self-restraining, then they may be formed into a unit load with no equipments. Storage equipments are used for holding or buffering the materials over a period of time. Some storage equipments may include the transport of materials. The materials are block stacked directly on the floor. There is no storage equipment needed. Identification and control equipment is used to collect and communicate the information that is used to coordinate the flow of materials within a facility and between a facility and its suppliers and customers. The identification of materials associated control can be formed or it can be performed manually with no specialized equipment. Material handling equipments can also be divided under three broad divisions like lifting and lowering devices, transporting devices in a horizontal motion, and the combination, that is transporting and the lifting. So whatever may be the classification based on which we are going to categorize the different material handling equipments, that is to be used in a very effective manner in an organization. Let us now see certain examples of the material handling equipments. The lifting and lowering equipments includes the winches, block and tackle, hoists, elevators, pillar crane and overhead crane. The lifting and the lowering equipments will have a vertical motion from top to bottom and bottom to top. Block and tackle arrangement of lifting loads is for a particular distance. This is one of the oldest and the simplest equipment. It is used even now by moving men and enforcing machinery into position. It depends in general on the manpower and gives only the mechanical advantage that is possible for the various rope formations. It is the most inexpensive equipment with a minimum cost and the most wasteful of the manpower. The winches. This is used to lift loads vertically by winding the rope or cable on a drum. It is possible to use the manpower or other power to get much greater mechanical advantage than with a block and tackle. It is frequently used in loading heavy equipment into ships, construction equipment into buildings and in similar jobs. Next is the power hoist. Power hoist is often operated between the fixed grid rails for lifting things vertically. This is an infinite variety of hoists suitable for different purposes. The simplest one is the chain hoist, which is operated by hand. There are also hoists which are operated by the compressed air or by the electric power. The hoists are similar to elevators, except that a hoist does not carry the operator in it, but it is operated from one to other points. Elevators. Elevators is differentiated from hoist by the fact that operator rides with the load. Although there are different types of drives for such elevators, in general, the only important type is the electrical one. Hydraulic elevators are now used only when it is prudent to avoid electric spark, as in the acetylene generated houses. Overhead cranes. Overhead cranes show an traveling of the materials over the floor space. Today, all the big workshops, namely the powerhouse, the chemical plants, huge repairing shops will have this overhead cranes. These cranes have an advantage of providing a large service area and freedom from obstruction on the floor. In all these movements, the driver controls with a seated in this cabin. Next comes the transporting equipments. The transporting equipments includes hand truck, wheeler truck, narrow gauge, railroad and car puller. The simplest transporting devices are wheelbarrows and hand trucks. These are still in use in a number of small industries all over the country. Both wheelbarrows and hand trucks are used to carry the materials inside the machine shops. All such equipments involve more manpower for relatively smaller load. The main advantage of these equipments is very low cost, greater flexibility and easy portability from one job to another. Narrow gauge railroad is of little use because it requires heavy investment in laying roadbed and trucks and have little flexibility. These were used in the days before the development of equipment having wheels and rubber tires. But still we find it in metalworking industries, but in mining work activities, this is said to be very cheaper to lay the tracks than to pave the entire area. The tractors and trailers are said to be the most common methods of horizontal transportation. Greater flexibility is achieved as tractors can be used to haul a variety of different types of trailers. Trailers can be lift loaded and picked up by different tractors. This is one of the most important methods of handling materials inside the plant and from one building to the another. Railway equipments. Where the plants are located at a considerable distance and the units handled are extremely large, such as in some steel rolling operations, the use of railway equipment is said to be an advantageous one. Then tramways is a horizontal transportation system in which the load carrying vehicle is supported from the top, usually by means of a table or its equivalent item. Skids. They are used with the lift trucks. Goods may be loaded into skids and can be picked up with the lift trucks. The skid can be loaded as a unit and transferred from one position to another position without subsequent loading and unloading. Both skids and pallets raise the load of the supporting surface and allow easy insertion of the conveying wheels. Some materials are stored in dollies and can be moved on their casters. Other materials are stored in skids. The most common skid, which can be picked up in either direction, consists of a wooden platform and 4 steel legs. The pipelines. Pipelines and pumps are used for horizontal transportation of the items. Most obvious among these is oil, which is pumped at a greater distance through the pipelines. Natural gas is also carried through the pipelines. Even the water is also transported through these pipelines. The combination equipment, that is lifting and transporting, includes spiral chutes, crane truck, dollies, form base skid, low lift truck, steel pallet, car dumper, air conveyor, power operated tailboard type, car conveyor, wheel gravity conveyor, escalator, roller conveyor, screw conveyor, roller spiral conveyor and portable conveyor. Chutes is one of the simplest equipment that has both vertical and horizontal motion. It can be either straight or spiral. Its gravity is used to move the material. Chutes are common in railway and airline terminals for handling the packages and baggages. These are also used in departmental stores in a spiral form to bring the stock reserves from the upper floors to the lower floors. Lift truck. This is a truck wherein there is a lifting feature and provides a clearance from the floor for the skids and permits horizontal transportation. Crane truck. Small crane trucks operate on the same principle like lift trucks. They are also used for materials that cannot be put on the skids. This moves quickly over a smooth, even, hard ground. In these cranes, solid rubber tires are used. The cranes are of a rotatory type, so that the loads can be lifted from any position. Forklifts. Forklifts are similar to auto trucks except for the development of tailboard called fork, which will receive the load at the ground level and elevate the same to the level of the truck so that manual lifting is avoided altogether. When a load is to be shifted from one shop to another, forklifts are used. Besides the driver, they do not require any additional manpower for lifting, carrying and unloading the materials. All these operations are carried out by the driver himself. Conveyors. If the path for the flow of material is fixed, then the provision of conveyors at suitable levels eliminates a good deal of lifting and lowering of materials. Conveyors requires no stopping or starting as they are continuous in operation. In these, transportation is effected by friction between the materials being supported by the belt. The advantage of the conveyors is that they save the labor cost, and the disadvantage being the occupation of considerable space in the floor area. The conveyors may be a belt conveyor, elevating conveyor, roller conveyor, chain or cable conveyor, pipeline conveyor and a screw conveyor. The belt conveyor consists of moving endless belts and carries materials on them. This has a power-driven pulley on one hand which moves the belt. Belt is made of rubber, fabric or leather. This conveyor is mostly used for handling larger quantities of materials like cement, fertilizers, coal, etc. Elevating conveyor is used for transporting dry granular materials in a vertical direction with the help of buckets and trays. Roller conveyor is used to transport various shapes of the products such as huge bags or materials that extend over several rollers. This type consists of rollers supported in frames over which materials are allowed to move. They are driven by power or gravity. There are different varieties of roller conveyors that can move the materials in horizontal as well as in vertical direction. Cable conveyor. This is moved by chains or cables in horizontal direction, and it is installed flush with the floor or little above it. This is used for moving the barrels and the heavy boxes. Pipeline conveyor is largely used for transporting dry or granular materials, chemical powder, sand, cement, etc. It can be operated by gravity, air pressure or some other mechanical means. Screw conveyor is a type that is used for transmitting the materials in the paste or powder form with the application of rotating screw. So these are all the various types of material handling equipments used in an organization. We shall now see the guidelines for the effective utilization of material handling equipments. As material handling adds no value but increases the production cycle time. Eliminate handling wherever possible. Ideally, there should not be any handling at all. Sequence the operations in a logical manner so that handling is unidirectional and smooth. Use gravity wherever possible, as it results in the conservation of fuel and power. Standardize the handling equipments to the extent possible, as it means interchangeable usage, better utilization of handling equipments and lesser spares holding. Install a regular preventive maintenance program for material handling equipments so that the downtime is minimum. In the selection of handling equipments, criteria of versatility and adaptability must be a governing factor. This will also ensure that investments in special purpose handling equipments are kept at minimum. The weight of unit load must be maximum so that each handling trip is productive. Work study aspects such as the elimination of unnecessary movements and a combination of processes should be considered while installing a material handling system. Non-productive operations in handling such as signaling and loading should be kept at a minimum through appropriate design of handling equipment. Magnetic cranes for the scrap movement and loading in furnaces, combination of excavators and tippers for ores loading and unloading in mines are examples in this aspect. Location of stores should be as close as possible to the plant which uses the materials. This avoids the handling and minimizing the investments in material handling system. Application of the operation research techniques such as queuing theory can be very much effective in the optimum utilization of material handling equipments. A very important aspect in the designing of material handling system is the safety concept. The system so designed must be very simple and also safer to operate. Avoid wasteful movements. To do the method study and conduct the studies to avoid these movements. Ensure proper coordination through the judicious selection of the equipment and training of workmen. So these are all the points to be considered while selecting the material equipment and for the greater utilization. The plant layout is related with the material handling. We shall now see what is the relationship between a plant layout and a material handling. A good layout will always ensure minimum material handling and eliminates rehandling activities. Material movement does not add any value to the product as discussed earlier. So, handling of materials must be kept as minimum, though we cannot avoid it. This is possible because of the systematic plant layout. So, a good plant layout will definitely minimize the time and the cost of material handling. The productive time of the workers will go without production if they are required to travel a long distance to get the materials. Thus, a good layout ensures a minimum travel for the workmen, thus enhancing the production time and eliminating the travelling time or minimizing the travelling time. The space should also be considered more important. Plant layout integrates all the movements of men, material through a well-designed plant layout with a material handling system. A good plant layout helps in building efficient material handling system in a shorter way and also in an economical way. A good layout reduces the material waste, backtracking, unnecessary worker movement, and ensures the effectiveness in manufacturing. So a good layout always ensures the minimum material handling. Material handling symbols. A symbol is a significant indication, mark, character or group of characters which may consist of figures, letters and signs chosen to typify or represent an idea or an item. A system of colored symbols facilitates the distinction and easy identification. The objectives of displaying the symbols prominently are to attract the attention and to avoid the accidents in a manufacturing plant. These are the certain symbols that are used in the material handling systems. Material handling system should be evaluated properly to know the effectiveness. The cost factors include the investment cost, the labor cost, the anticipated service hours per year, its utilization and unit load carrying ability, loading and unloading characteristics, operating costs and the size requirements are the factors for evolution of material handling equipment. Other factors to be considered are the source of power, the conditions where the equipment has to operate and such other technical aspects. Therefore, the choices of the equipments in an organization will improve the material handling system through the work study techniques. They usually result in improving the ratio of the operating time to loading time through palletizing, avoiding duplicative movements, etc. Obsolete handling systems can be replaced with more efficient equipments. The effectiveness of material handling system can be measured in terms of the ratio of time spent in handling to the total time spent in production. This will cover the time element. The cost effectiveness can also be measured by the expenses incurred per unit weight handled. It can be safely said that very few organizations try to collect the expenses and the time in this manner so that the performance can be objectively viewed and to take the remedial measures if there is any discrepancies. The following ratios will be calculated to know about the effectiveness of the material handling system. Material handling time ratio, material handling cost ratio, material handling labor ratio, material handling direct labor loss ratio and material movement operation ratio. Material handling time ratio is computed to know about the time spent in material handling versus the time spent in the production. Material handling time ratio is equal to time spent in handling divided by the time spent in the production. That is the proportion of time spent in material handling to the total time spent in the production is calculated. The material handling cost ratio. This ratio is computed to know the per unit cost of materials handled versus the total cost of material handled. That is, per unit cost of material handled divided by the total cost of material handled. Material handling labor ratio. This ratio is computed to know about the total labor hours required for handling the materials, which may be computed as follows. The staff engaged in material handling, that is the labor hours, divided by the total operating staff hours. So we can put it in the terms of hours or in terms of the number of employees. If it is labor ratio, in terms of employees. If it is labor hour ratio, it is in terms of hours. Material handling direct labor loss ratio. The time lost by the direct labor in material handling divided by the total time taken by the direct labor in material handling. So what is the total time spent by the direct laborers in material handling and what is the time lost? So the proportion is studied. Material movement operation ratio. This is mainly computed to know about the productive operations versus unproductive operations. Total number of movements divided by total number of productive operations. This ratio will facilitate to know about the total number of movements and the total number of unnecessary movements which can be cut in the future operations. So in case of work study also, they will have a study regarding the total movements required. Then they will categorize as necessary movements, unnecessary movements and incidental movements. The necessary movements and incidental movements are said to be productive. The unnecessary movements are said to be not productive, that is unproductive. So when we have the necessary movements, they are said to be the major movements in material handling. Incidental movements which will help the major movements, but it is necessary but cannot be avoided. But certain unproductive movements can be avoided. So the materials movement operation ratio is calculated. So to know about the effectiveness of the material handling or to measure the performance of the material handling, we can calculate material handling time ratio, cost ratio, labor ratio, labor loss ratio and movement operation ratio. The efficiency of material handling mainly depends upon the factors like efficiency of handling methods employed for handling a unit weight through a unit distance, efficiency of layout which determines the distance through which the materials have to be handled, the utilization of the handling facilities and the efficiency in the speed of handling. So we have to decide what is the unit load and the unit distance, and the layout of the factory will determine the distance, then the handling facilities utilization and the speed of handling. So these are all the main factors to decide about the efficiency of the material handling. So it can be said that effective material handling system depends upon tailoring the layout and equipments to suit the specific requirements. When a large volume has to be moved from a limited number of sources to a limited number of destinations, the fixed path equipments can be used. For increased flexibility, the varied path equipments can be preferred. So in this unit, we have studied about the significance of material handling, the various principles in the material handling, the various material handling equipments and the measurement of the performance of the material handling system. Thank you.